let us start our discussion on proof of tan phi u is equal to r into d theta by dr and polar coordinate system. But before going to this proof, we should understand what is mean by polar coordinate system. The polar coordinate system means what? And the difference between Cartesian coordinate system and polar coordinate system. In case of Cartesian coordinate system, the point is represented by x and y, which are represent the distance, perpendicular distance from the x-axis and y-axis. The origin is 0, comma 0, and I can say that there is a rectangular grid is there, all those things. But in case of polar coordinate system, the points is represented by two things, that is r and theta, where r represents a distance of that point from the pole, and the theta will represent the angle. That distance is called radius vector, and that radius vector makes an angle with the theta with the x-axis. What is the angle that radius vector makes with an x-axis? That is called, we can say that theta, it is represented by theta. Okay, now if you want to convert, if the given point in the polar coordinate, we can find convert into the Cartesian system. Means what? If the point given in the polar coordinates, we can say at what position it is there in the coordinate system. You can say that means, it means that suppose the point is given is, let me take, this is the point r and theta. Now if I say r and theta, I can say that based on this r and theta, we can say how much distance it is there from the x-axis and how much distance from the y-axis. We can say that by formula x is equal to r cos theta and y is equal to r sin theta. Why? Because why x is equal to r cos theta and y is equal to r sin theta? Because see here, if you draw perpendicular here, just draw perpendicular here, and we can say that this is adjacent side and this is r as a hypotenuse, and this is perpendicular here, and this is theta. Cos theta is equal to adjacent divided by hypotenuse. We want adjacent, therefore adjacent we call that is x is equal to, this is the distance of this point from the y-axis, that is represent r cos theta. Therefore by r cos theta we can say that how much distance from the y-axis, that is represented by x here. Similarly, r sin theta here. R sin theta means how much distance from the x-axis. We can say that r sin theta will represent how much distance is there, the point is away from the x-axis. Okay, that is what uh, r sin theta will say about that. Okay, point. Now, because if these oppose sin theta is equal to opposite divided by hypotenuse, this is, we want actually opposite, we want, that is perpendicular distance we want, that is y coordinate we want, opposite divided by hypotenuse, opposite is equal to r sin theta. This is why if the point is given in polar coordinates, you can say that, or you can tell about the x and y coordinates by using this formula. This is why we can say like that. Okay, now coming to the basic point again. Now we understand what is the difference between polar coordinates and Cartesian coordinate system. Now coming to the proof of this, why we are going to use this proof, what is the necessity? Because this is very necessary in the finding the radius of curvature in the polar coordinate system. We should know how, we come to know after that all those things, at not at the next video we're going to say how we are using to find out the radius of curvature and all those things, and pedal equation also we are going to use this tan phi. We come to know, before that we should prove this one. Let us coming to the proof again. We have polar coordinate system, means there is a point is represented by r and theta, where r represents the distance of that point from the origin, and theta is the radius, the angle made by this radius vector with the x-axis. And if you draw tangent at that particular point, we can say that draw that tangent makes an angle with the x-axis, that is called psi. And if you draw perpendicular from the origin to the t, that is called to the tangent, that is called ot, will make the perpendicular to the tangent t. And with these basic construction we can find out this tan phi, because these are the basic necessary given conditions are there. Under these conditions we need to find out the tan phi here. Okay, if these given conditions is given, what is this? They given polar coordinate system. Once the polar coordinate, you can draw tangent, no problem. Nobody will restrict you to draw tangent at this point, particular point here. We can draw tangent, and I can say that uh, and this is actually when we can make an perpendicular here. Definitely after drawing a tangent, we can immediately we are going to get two angles here. One then is psi and one is phi. We can mention it now. This is very important, psi angle. What this psi angle represent? The psi angle represent, if you make a tan phi represent the slope of the curve at a point P. That is very important. Tan psi will represent the slope of the curve at a point, because we already know that any slope of the curve at a point is equal to the slope of the tangent drawn at that point. If I want to find out the slope of the curve at a point P, I need to draw tangent at that point. And if you find out the home, and you just simply after drawing a tangent, if you measure the angle with the x-axis, how much angle makes with an x-axis with that tangent with x-axis, and if you find out the tan of that angle, we can easily say what is the slope of the curve at that point. These things, we basic things we know that. Okay, with these things, let us, okay, once if I say that tan phi is equal to dy by dx, and one more thing, this psi is there, no, which is equal to the sum of opposite interior angles, because according to the sum of, already know the exterior angle property in a triangle. This is an exterior angle, this exterior angle is equal to sum of opposite interior angles. These things are known in high school classes, no problem. Okay, now coming to the thing is, with these things, x is equal to r cos theta and r y is equal to r sin theta. Here, keep in mind r is a function of theta here. R is a function of theta, and cos theta is a function of cos theta, no problem. Next, and what we can use the product rule here in order to find out dx by d theta. Dx by d theta is equal to keep product rule. You can keep this, if you consider this is the first function, keep the first function as differentiation of the second function dr by d theta, and keep the second function as it is, that is r, and differentiation of this first function, that is minus sine theta. Dx, we can say that dx by d theta I can find out, dy by d theta I can find out. Similarly, after that we can find out tan psi. Tan psi is equal to dy by d theta and the whole divided by dx by d theta, and just divide, you in the numerator you put the value of dy by theta, and numerator denominator you put the value of dx by d theta, and after doing these things, and divide the numerator and denominator by dr by d theta into cos theta. But just for simple, we now to what we are doing, why we are doing like this, because you will come to know at the end, after divide the numerator and denominator, this will going to become like this. And this psi can be can be written as tan of theta plus 5, and which is equal to in order to compare these things, we are going to divide this dr by d theta into cos theta. Therefore, after dividing this numerator and denominator dr by d theta into cos theta, tan psi is equal to tan theta plus r into d theta by dr whole divided by 1 minus r into d theta dr into tan theta. Now, already told you that psi is equal to theta plus 5. Therefore, tan of theta plus 5 by tan of a plus b, you can say that tan theta plus tan 5 whole divided by 1 minus tan theta into tan phi. By comparing these things here, tan theta is there, tan theta, and instead of tan phi, r into d theta dr is there, 1 is there, and tan theta is there. Again, we conclude that tan phi is equal to r into d theta by dr. This is how we can prove it. Very simple logic. Only thing, these are the, whenever the polar curve is there, definitely we have two things, and you can draw tangent. And by doing this tan phi with known things, we have proved what we know. We know that tan phi is equal to dy by dx, and based on that x, you can say that x can be written as r into cos theta, y can be written as r into sin theta. By product tool, you can rewrite like this. By known things, we have proved this. What we have known, there, whenever the polar curve is there, there is a curve and there is a radius vector, and once it is, it can draw a tangent which makes an angle psi with x-axis, and after that we know that tan psi is equal to dy by dx. With these known things, we have proved. That's all.